name is Anusit Vashiracharanmong, and today, as a part of seminar self-learning project, I'm going to present you about the reinforcement learning. So first, let's look at the content of this presentation. So first, what is reinforcement learning? You will learn what is reinforcement learning and basic of it. Second is the Markov decision processes, or MDP. It's the special mathematical algorithm that involved with reinforcement learning. Next is the Q-learning, which is also another algorithm. And the last one, I will show you a real reinforcement learning using Q-learning to a game called Fossil Lake. So let's get started. The first one, what is reinforcement learning? So reinforcement learning is a type of machine learning that involve training an agent to make a decision based on the reward it receives for its action. The goal of reinforcement learning is to teach an agent how to make the best decision possible based on the available information, with the goal of maximizing the total reward it receives over time. So imagine you are teaching your naughty dog to sit on a chair and not to jump. So if the dog sits, you give it a treat. If a dog jumps, you scold it. And over the time, your dog will learn to sit because it do not want to get scolded and it want a treat. This is similar to reinforcement learning. So when you do something right or you reach the goal, you get a reward for that. And the goal of reinforcement learning is to maximize those reward. Okay. So in this scenario, I will explain the element of reinforcement learning. First one is the agent. In training a dog, the agent is a dog, and the agent will interact with the environment. In this case, is the trainer or you. You are the environment of this scenario, and the goal is to maximize the treat or to get the more treat as possible. Okay, so now you understand a little bit more about reinforcement learning. I want you to understand an important concept called Markov decision processes. Okay, so let's go to Markov decision processes. Markov decision processes are a way to model a reinforcement learning problem, and MDP is a mathematical framework that consists of a set of state, action, reward, and transition probability. Also, the episode and the step that will be explained later. The goal of an agent in an MDP is to learn a policy, which is a mapping from state to an action that maximizes expected reward. Or in other words, MDP capture everything in reinforcement learning, and a goal of agent in MDP is to learn a thing called policy, which maximize the reward. So now let's look at the element of the MDP. So the first one is a state. A state is a representation of the environment at a particular point in time. It captures all the relevant information that the agent needs to make a decision about what action to take. For example, in this state, in training a dog, a state is still because you want a dog to steal before training. There are only one state. Second one is an action. An action is a decision made by the agent based on the current state. It determines how the environment will transition to a new state. For example, in this case, since there are only one state, there are two actions in that state. Is from stealing, the dog can choose to sit on the chair or jump. The next one is reward. As I told you, reward is a numerical signal that the agent receives after taking action in a particular state. It reflects how desirable the new state is to the agent. In this example, reward is a treat, and If you get a reward, you get a +1, and if you get score, you get -1. Next is the transition probabilities. So before understanding transition probabilities, I want you to understand the word episode. So episode is a sequence from start training to stop training. So let's look at the first episode, episode 1. So for the first episode 1, the starting state is still, as I told you, there's only one state in this scenario. The dog will stay still. And in the action, the dog chooses to jump. And when the dog chooses to jump, it gets cold. And this is the end of the first episode. There are only one step in this scenario because this is a very, very small but easy to understand scenario. The steps are in the middle. In this step, you choose to do an action, and the action available are jumping and sitting. Okay, so at first episode, the dog jump and gets cold, so it learns. The next episode, it starts still again, then it sits. Now it gets reward. So now the dog know if it sits, it get reward. So the goal of MDP is to maximize the rewards over time. So the dog learns to sit on the chair. This is a transition probability that it learns to get a reward over time. Okay. So now you have understand more about reinforcement learning. You now understand what is reinforcement learning and what is MDP. The next concept I want to introduce you is acute learning. So acute learning is a specific algorithm designed to operate within the MDP framework. It involves updating estimate of the Q value of state action pair based on the reward received by the agent and the predicted value of the next state action pairs. This updated occur during each step of the agent interaction with the environment and over multiple episodes. Okay, so going to our example about training dogs, since this is a very small scenario, as I told you, you may not fully understand the concept of Q-learning, but I will give you a taste of what Q-learning is. So look at the table. The first table is called the Q-value table. So the Q-value table consists of two columns, is the state and the action. Since in this scenario there is only one state, is still, so there's only one row there, and there are two actions to sit or jump. In the start state, all Q value are initialized to 0. During each episode, the agent observes the current state of the environment or the still state, and it selects action to take either to sit or jump, and it receives a reward from the environment, either 1 for sitting or -1 for jump, and it transitions to a new state based on the action it took and the current state of the environment. However, there's only one state in this scenario, so the transition to the next state is going to be a still state again. So let's say in the first episode, the dog choose an action to jump. The Q value of the dog in the Q value table will update to -1. Now the episode ends and the dog already learned that jumping will get a negative score, and it transitioned to a new state based on the action it took. Since it jumped, then it go to still again. Now it's know that going to jump is reduce the points, so the dog choose the action to sit now. When it sits, the Q value in the table update to 1, and now the dog know that it's a good idea to sit. Okay. So first, you get to learn what reinforcement learning. You understand MDP and you understand basic concept of Q learning. So I know there's a lot of theory and there's a lot of it going on now, but I want you to follow me to the code where the visualization will help you understand easier what is going on. So I want to implement a game called Frozen Lake game to the Q-Learning to show you how reinforcement learning is really done. So from the website of Frozen Lake games, it say winter is here. You and your friends were tossing around a frisbee at the park when you made a wild throw that left the frisbee out in the middle of the lake. The water is mostly frozen, but there are a few holes where the ice has melted. If you step into one of those holes, you fall into the freezing water. At this time, there's an international frisbee shortage, so it's absolutely imperative that you navigate across the lake and retrieve the disc. However, the ice is slippery, so you won't always move in the direction you intended. The surface is described using a grid like this. So simply, this is the goal of the game. Like you walk on a frozen lake and not to fall in the hole and to get the frisbee you left in the park. So let's look at the everything we need to know about this game first before going to the code. So there are 4 action spaces that the agent take. It is a one element vector for action. The space is the where the desired direction to move in which can be left, down, right, and up. So now the agent can move in the 4 direction. Keep in mind of that. Next is the observation space. Uh, the observation space represents the agent current position as current row multiply row plus current column, where both the row and column start at 0. For example, the goal position is in the 4 times 4 map, can be calculated at 3 times 4 plus 3 equal 15. The number of possible observations is dependent on the size of the map. For example, 4 multiplied 4 map has 16 possible observations. Okay, so now you understand about the observation, the action space, and now the rewards. So if you read the goal is to get the frisbee. If you get a frisbee, you got +1. If you reach the hole and fall into it, you got 0 point and the game is end. If you read the frozen, there are no negative point and you can keep moving forward. And the last one is the start spot. It's the start state where everything is still is a 0 point also. I hope now you understand everything about the game. So let's move on to our code. Okay, so let's really start everything. Okay. Okay. First, we import the necessary library involving this game. The one I want to emphasize is this one, Gym. Gym is a built-in library from OpenAI that have a built-in Frozen Lake game that you can try on your own. So now we want a Gym to make a Frozen Lake game. Now we get the action space and the state space from our environment. Okay. Next, we create a Q table consisting of state space and action space. Since I told you there are 4 action and 4 state space, so the Q table is 4 times 16. Oh, sorry, there are 16 possible things in the Q table here. So let me print it again. Okay. Next, we define the number of variables. The first one is the episode. So we define there are 10,000 episodes in this game, and in each episode there are maximum steps of 100. We define a learning rate of 0.1 and discovery rate of 0.99, the exploration rate of 1, max exploration rate of 1, mean exploration rate of 0.01, and exploration decay at 0.01. Don't worry, you didn't understand this learning rate. This is to reduce the learning rate of the Q learning algorithm. So if the learning rate is high, if the learning rate equal to 1, it will directly replace that specific value. So for example, this cell have value 1, Or in another example, this cell have value 0.7 and you got a new value for them. If the learning rate equal to 1, the new value will directly replace it, but if reduce, it will decide and choose to replace it or not. Okay. So now the Q-learning algorithm. It's very simple actually. So first we define an array of reward of our episode. Then we iterate in range of number of episodes, 10,000 episodes. In each episode, we want the environment to reset, and we want to set the reward each episode in the step. So there are two things called exploration rate threshold and exploration rate. Exploitation rate and exploration rate. Okay, so explore is to move and look around what going on in the environment, and exploit is to use the information you get from the exploration to take advantage of the game. This is exploit. So in this code, basically, if you get enough information and you think it's good time now to use that information to win the game, you just do it. Okay, so in the code, we just iterate, go and make the machine learn and train about the Fossil Lake game when we run it. Okay, so we want to show you an average reward per 1,000 episodes. Since there are 10,000 episodes, if I show it all, it will be too long. So at first, it starts at only like 5%, 5.4% accuracy, but after like 10,000 episodes, it got an accuracy of 67.5 of winning the game. So that's very good. This is the training part. So if you train more, there's a better chance of the model or the algorithm you're going to do. There's a better chance of it to get better, but don't train too much or it will be overfit. Okay, so now we want to test it in the game. So this code is just rendering out those shell and let the agent play it. So let's see. As you can see that in each episode, the agent tend to finish the game faster and faster because it incrementally learn. And if there are enough like episode, I'm sure that this agent can finish this game in just 5 seconds. So that's all for my presentation to understand more about reinforcement learning, and thank you for watching.